Oh, now did you complete the 15 iterations of this experiment that I asked about yet?
You know, if you just stayed 6 more months, you could get that one more paper done.
Welcome to Hello PhD, a podcast for scientists and the people who love them. This week on the show, we discuss 8 ways to make biomedical research a more sustainable place. It's not even a sentence.
What are you talking about?
Biomedical research isn't a place.
And we're back. This is Hello PhD, episode 11. I'm Joshua Hall.
And I'm Daniel Arneman.
And we'll discuss the human side of scientific research and life in the lab. How are you doing, Daniel?
I'm feeling great. How are you?
I'm feeling quite well myself. You know, we have a special episode coming up.
Oh, I'm excited about this. What's going on?
It came to my attention that National Postdoc Awareness Week is coming up.
I'm not aware of postdocs. What are those?
I think I said that wrong. I think it's Postdoc Appreciation Week.
Oh, I am.
Do you appreciate postdocs?
I wasn't aware of them. So I guess I did not appreciate them. I don't know.
Well, you know, I appreciate postdocs, having been one, and I know you appreciate postdocs
and
too.
I'm interested in learning more about these postdocs.
Well, you are going to get your wish, because what we're going to do is we're going to just talk to a bunch of postdocs.
Interesting. Do these people exist somewhere?
Well, I hope so. So what we need are you, the postdocs, to get in touch with us. You can email us at podcast@hellophd.com, or you can send us a quick tweet at hellophd, and just let us know if you are willing for us to ask you a few questions, and we would love to possibly use it on the air.
This seems like a good thing that if we have some grad student listeners and they happen to spot a postdoc kind of in the wild, they could pass on that message and we could talk to the postdoc that way.
That's true. You could go Cecil the Lion on the postdoc.
Too soon.
Too soon.
Too soon.
Too soon.
We're going to
Sorry
get
about
hate
that.
mail.
Yes, if you are a postdoc or you know of a postdoc, please send them our way. We would love to talk to them. It'll just take a minute.
Perfect. So, can we talk about some data?
Yeah, so I have actually been crunching some data this week, Dan.
Sounds like a good habit to be in.
Yeah, so I was looking at the people who have listened to Hello PhD so far. Did you know that we have had listeners from 43 different states?
That's fantastic.
It is fantastic, but, you know, being the pessimist that I am, I was interested in saying, who are these 7 states
Oh, yeah, the outliers.
where we have not had a listener?
Interesting.
Okay,
Who's on the list?
before I tell you that, I'm going to tell you about one other little piece of information.
Okay, you got more data for me.
I do. As you know, what is an important part of our show that we always do at the top of the show?
Oh, the ethanol, probably.
Drinking beer
Yeah,
has been a big part of this show.
certainly the first part, at least.
So I was also looking into states that are known for their beer.
Okay, so now we've got some kind of Venn diagram I'm going to have to look at.
Yes, so I looked at a very scientific study from Thrillist.com,
Okay, that sounds like a heavily researched site.
and we will certainly post this article, but they listed, very scientifically I'm sure, states in order from worst to best by their beer.
Oh, do we get to hear the worst, or are we just going to hear the best?
Well, so what I did was I was interested in correlating how good a state's beer was with their likelihood of listening to Hello PhD.
Okay, let's see it.
So the states that have not listened to Hello PhD are Mississippi,
Okay, I've never had a Mississippi beer, I don't think.
North Dakota,
I'm not aware of a North Dakota beer.
Hawaii,
Probably.
New Hampshire, Wyoming, Arkansas, and Oregon.
These are the ones that have not listened to Hello
These
PhD.
states have not listened to Hello PhD. So what was interesting to me is 6 of those states, the first 6 ones that I just mentioned, are in the bottom 12 for their beer ranking.
So basically, people who love beer listen to Hello PhD. People who don't do not listen to Hello PhD.
I think that's true. Because
But you said 6.
yes. So this is what threw me. I got to mention it. So as I said, 6 of the 7 states that have not listened to Hello PhD yet are in the bottom 12 of beer states, except Oregon, which was number 1
For best beer
for
state?
best beer in the nation.
Oregon, come on, help me out.
So we need you, listeners. you got to let Oregon know. They're going to love this podcast.
So we need to blaze the Oregon Trail
We
with Hello PhD
do.
to
And
get some listeners there.
we need your help. So this is what we're going to do. We feel strongly that the grad students and postdocs and researchers of Oregon really need to hear Hello PhD. So if you know someone who does science in Oregon, a grad student, a postdoc, anyone who works in a lab, please let them know this week. We can check the stats and send us an email. If you let somebody in Oregon know and they said they listened, we will give you your own shout out on the show.
Awesome. And does this explain why my bottle of beer says Oregon beer?
That's right. To show how important this is to me, the beer we are drinking this week is one of my favorites. This was actually one of my favorite craft brews when I first started drinking craft brews. This is Rogue Dead Guy Ale.
Now, is this made mostly from Dead Guy, or is that just one of the minor ingredients?
That is unclear to me, but this is a
Tastes
good
great.
beer. This is a fantastic beer. It is a winner. Rogue Dead Guy. So all of you who are in Oregon right now or know people in Oregon, because the people in Oregon are not listening, we're showing how much we're into this by even drinking your beer right now.
Beautiful amber color, a little bit malty, a little bit sweet. I get some hops at the back. It's very nice.
Yeah, and you can find this beer a lot of places. I've seen this beer a lot of different spots across the country. So chances are you can probably find this at your local beer establishment.
This will be great. So people will hear this episode in Oregon, and they will enjoy hearing about their hometown brew.
That's right. That's right.
Well, do we have something else that we can talk about today other than our love of Oregonians? Or I don't even know how to say that.
Well, that was obviously the most important thing I wanted to talk about. But I think I mentioned last week on the show there was a paper that we covered in my staff meeting that I thought was really, really interesting that I'd like to talk about. And it's a paper that came out just recently. It came out in September in Proceedings of the National Academies of Science.
Okay, I like that one.
Or PNAS.
Yep.
Or PNAS.
Nobody calls it that. Nobody calls it that.
And so this is a great article. This article is entitled Toward a Sustainable Biomedical Research Enterprise, Finding Consensus and Implementing Recommendations.
That's a bit dry. Can you distill it for me?
Yeah, so let me tell you about what they did. And this is what I thought was fascinating about this article. So what the authors did was they systematically searched lots of different reports since 2012. And they looked at articles, meeting summaries, and opinion pieces that addressed the research enterprise broadly and looked at the sustainability of that enterprise. So what are the things that are going on in biomedical research right now? What are the problems that are a threat to the long-term sustainability of biomedical research?
And you don't mean the word sustainability like they're green and eco-friendly. You mean like they will continue to exist for a long time or they won't.
Exactly. What are the things going on right now in research that are driving it into the ground? What things need to change?
You want me to make a list? Oh, they did.
They did. Spoiler alert. But what's cool about this was they looked at all these reports, they narrowed them down to these consensus reports, and then of all these recommendations, they said which recommendations kept popping up over and over and over again.
What does everybody agree is a problem?
Exactly. What, as they said, are the consensus recommendations that lots of people agree these are real issues that we need to address. Okay, and so they narrowed that down to 8.
I think we can handle 8.
We can handle 8, and we're going to.
And when they publish their next article, they will take our opinions and form a consensus based on our opinions.
I'm sure. I hope we are included in the next meta-analysis of biomedical research problems.
Please call us.
We think there should be fewer podcasts about biomedical research.
Just one is sustainable.
That's right. All right, so number 1 is the federal government should make research funding predictable and sustainable.
I mean, right off the top, that kind of rings true to me. I remember when we started graduate school, I think it was just after the Clinton administration had quadrupled the budgets, and everybody had 2 R01s or 3 or 5. It didn't matter if you were researching the dumbest topic on earth and you had no prior history of doing something useful, you got a lot of grants.
Yeah.
But as we went through school, it dried up.
Yeah, a lot of the listeners now, especially the grad students out there, have really entered the training environment in a very different environment than what we did. You're absolutely right. So
They don't just have like money fights like we did.
in 1994, actually,
I lit my Bunsen burner with a $100 bill every day.
we all did. We all did. Actually, they were just purchase orders, but
Okay,
you
whatever.
get the drift. Yes, the Clinton administration, under the Clinton administration, they doubled the NIH budget, right? And so I remember there were lots of new faculty being hired. It was very
Oh, the building campaigns were incredible. They
buildings going
doubled
up
lab
everywhere.
space and things like that.
Absolutely. So what I was curious about is, well, what do they mean by predictable and sustainable? What is the problem they're trying to address? And so as I dug into this a little bit, so it requires a little bit of understanding of how the United States federal government works, how their budget works.
We only have a 30-minute podcast.
Well, so what I did when I want to understand anything is I went to my favorite resource, Google.
Okay.
Okay, and I discovered a website, nationalpriorities.org, that does a nice job of breaking down the federal budget into understandable charts and graphs. And you like charts and graphs, Dave.
I do indeed, although I do not like pie charts, and that's what I'm seeing on your screen right now.
The pie chart is my favorite type of chart.
Well, then you and I are at odds.
That's the next episode, a throwdown over pie charts. But it turns out the federal budget can be broken into three big wedges. There's mandatory spending, discretionary spending, and interest on federal debt.
That is an obtuse angle. That is not a wedge, sir. That is more than 50% for that big green circle.
This is how it's going to be.
Yeah, it is.
So the discretionary spending, or the spending that Congress and the president actually bicker over year in and year out, makes up about a third of the budget. So all the back and forth you hear every year for the federal budget is this third. Now, what's interesting is all of the spending on science comes from that third.
From the discretionary budget.
From the discretionary budget. And what's interesting, if you drill down into the items in the discretionary spending, science is one of the only wedges that does not also have a corresponding wedge in the mandatory spending. So what we mean by mandatory spending is this is money that has been appropriated through other means that is just there year after year. Congress said Social Security is a good example of that. They said, we think people of this age will get this benefit. And so the number of people...
It's tough to change it year to year.
Exactly.
Yeah.
So science actually is in that wedge that is discretionary spending.
Purely discretionary.
It makes up 2.67% of discretionary spending and only 0.78% of the overall federal budget.
And so, aside from the wedges and the pie charts, this manifests as people who are given grants and research funding having that money either difficult to obtain when they try to renew, or I've even heard cases where people's budgets were cut after they had already been promised that amount.
Yeah, so therein lies the problem.
It's like, here's some money. Oh, just kidding. You have to give it back now. Well, what if you spend it?
That's right. So the funding agencies in science, which are mostly federally funded, don't know from year to year how much money there's going to be the next year.
So they're actually trying to give out a 4-year research grant, and they don't know what's going to happen in 2 years?
Exactly.
That's crazy.
And so a lot of people have identified that uncertainty as a problem, and it's actually not been great to the effectiveness of the scientific research enterprise to have that up and down nature of funding. If there was a more predictable, sustainable amount of funds available for scientific research, there could be more planning and more thought that could go into it. And also perhaps along with that, you could put a little more thought long-term into, well, how many people are we paying off of federal grants right now? What are the infrastructure needs? These are not the types of things that are being looked at right now.
Yeah, and we've personally known people that their jobs kind of evaporated, or other people in their lab, their job went away, and the lab managers and the PIs had to make really tough decisions about letting go the good people, the best people, because the money just went away.
Absolutely. And so
you can't make a plan. You can't run a lab if you don't know how much money you're going to have.
No, that's totally true. And so what really surprised me as I started looking into this was that science was one of the only categories that was like this, that was in a purely discretionary spending class. And so that was actually the first recommendation. So the second recommendation is related to that, and it quite simply is the federal government should increase overall research funding. So similar to what happened in 94, which research funding has been fairly stagnant since then, the next recommendation is we just need more money for research.
Okay, so I'm totally with you on the first one, that it needs to be stable and predictable so that you can make a plan and a budget. The second one is a little bit less clear to me, because I definitely observed plenty of bad research and plenty of money wasting because it was so abundant.
No, that is certainly true. And, one of the the arguments for supporting scientific research is that scientific research actually can be viewed as an investment that could actually lower costs. And so one article that made a big splash back in the spring, Dan, maybe you read this, was an opinion piece in the New York Times called Double the NIH Budget. Do you know who wrote that article?
Was it Bernie Sanders?
It was not Bernie Sanders, but that's a good guess. It was not Hillary Clinton. It was Newt Gingrich.
Oh, wow. That guy's still around?
Conservative,
Yeah.
former presidential candidate, former Speaker of the House, Newt Gingrich.
And what was his reasoning?
So what Newt said, man, I love that his name's Newt.
Yeah.
That's great.
I'm going to turn that into a word puzzle later.
So what Newt said, and I want to read this because I think this is interesting, and I think he brings up a good point. So Newt says, even as we've let financing for basic science and medical research stagnate, government spending on healthcare has grown significantly. That should trouble every fiscal conservative. As a conservative myself, I'm often skeptical of government investments. But when it comes to breakthroughs that could cure, not just treat, the most expensive diseases, government is unique. It alone can bring the necessary resources to bear, and it is ultimately on the hook for the costs of illness. It's irresponsible and short-sighted, not prudent, to let financing for basic research dwindle.
I mean, it's a really interesting argument that you pay the money here and get the money back there. I like the idea of it. I wonder if there's a way to structure the grants such that you are actually investing in these health-promoting technologies and not just researching the next amino acid in some random protein that nobody has no health effect.
I found it interesting that he actually used the terminology financing for basic research. That, to me, actually showed a little bit of understanding of how scientific breakthroughs work, that they aren't always the research that's directly studying the problem, but sometimes these really, really big breakthroughs can come from basic research
It's
questions.
totally true. It's a bit of a gamble, but as the money kind of dried up, I noticed grants started going to people who were doing really incremental changes with experiments that were already 2/3 done, showing the next obvious step. You know, there was not a lot of exploratory work, and there wasn't a lot of kind of pie-in-the-sky work. So
that's totally true.
There's got to be a balance there somewhere.
And I think there are lots of discussion points related to that we should talk about. But, you know, Dan, you and I, having been biomedical researchers and been in that world for a while, I would say we are both fairly skeptical and cynical about research directly leading to medical breakthroughs.
I wasted some money as a grad student on a number of occasions.
But here's why I think that's okay for the economy. So what I thought about was, let's think about that money that the government gives out for research grants. What's being done with that money?
Yeah, I guess it's going to train students and to perform experiments.
Yeah,
right?
well, I'm thinking about, the money your PI got when you were a graduate student was used primarily to pay you, right?
I enjoyed it. Thank you.
And you paid taxes on that, right? So there's employment, which that's good. Jobs.
I bought a lot of bovine serum albumin, which cost a lot of money.
You did. So the primary things PIs do with this money is they employ people who pay taxes. So some of that money returns directly to the government. And then people buy supplies to do their research. And at least in my experience, most of the supplies we bought were from American companies.
Oh, is that right? And we were supposed to pay taxes. Could you not mention that again, please?
If you're out there getting paid as a grad student or postdoc,
you didn't get an envelope of cash every week from your PI? I don't understand.
Please be paying taxes or withholding for your taxes. Okay. Although I am not authorized to give you tax advice.
Okay, fair enough.
I'm deleting that part out.
This one's a bit of a double-edged sword, and I think it can be done in a good way, but just on the surface, I think it could also be done in a bad way.
I think that's true.
What's number 3? We got a bunch more to go.
All right, so number 3 is federal agencies should harmonize, streamline, or eliminate burdensome regulations. House Bill 1119, the proposed Research and Development Efficiency Act of 2015, would establish a federal working group to identify burdensome or outdated regulations.
I just love this one. I think we should get rid of all IRB approval and do as many human experiments as we possibly can. I read this one and I had no idea what they were talking about. What burdensome regulations are there?
I'm not sure, and I admit...
I want to be able to kill animals in plain sight of school children whenever I want to.
I have a lot on my plate, so I did not have time this week to... dig down deep into House Bill 1119. I really, really lost time at 1117.
Okay.
But, one thing that I think is important to recognize, and maybe one of the things they're talking about, is there's been some studies out there that talk about loss of productivity of the principal investigator, right? And Dan, I don't know, you've been out for a little while, but one thing that I see and that I hear PIs talk about and complain about all the time is they have very little time now to actually do research. I was in a lab the other day, and a PI, I had a meeting with this PI. The PI was out in the hallway talking to his postdoc, right? And he said, "Hey, do you mind just waiting a minute?" Like, no problem. So I waited in his office.
Were you eavesdropping?
I was not. I
Okay.
was not. I was probably playing Yahtzee on my phone or something like that.
Yeah.
So he came in and he said, "Hey, I apologize, but that's the first time I've been able to have a conversation with this postdoc for a week because I've been so busy writing grants, doing paperwork, that I don't have time to even have informal conversations about research with the people in my lab anymore."
But the writing of grants, and grants come with paperwork, certainly. Are those bureaucratic requirements? Are those from the government, or is that just the part of grant writing?
So a lot of those they're part of the grants process from the federal government, whether it's NSF or NIH. There's been a lot of complaints that those are very burdensome. The reporting requirements. Some of those are institutional requirements that PIs have to deal with. And so there was a recent report by the NSF on this very thing, and they found that 42% of PI's time on average was used towards administrative tasks and paperwork. 42%. And one thing that was interesting about this...
That sounds boring.
It's terrible, and something tells me that that's probably not what drew these individuals into science in the first
I promise
place.
it's not what drew them to science. And it's probably not what they're good at or in love with either. I mean, you get to be a PI because you do well at the bench and because you can plan experiments and execute them. You don't get there because you're a bureaucrat.
Absolutely. And, this is something we had some discussion about in my team meeting. And I think another sort of downstream effect of this is not just in the life of the PIs now, but think about these really creative and talented minds who are graduate students, postdocs, even undergrads, who are observing what their PI's life is like. And they say, you know what? That looks terrible.
Can I please spend 42% of my time filling out paperwork?
Right. And so it actually could be a detriment to young researchers who are observing this and saying, I don't want any part of that.
Yeah, that's great. What was number 4, sir? I'll read it for you.
Read number 4, Dan.
Okay. Number 4 was institutions and federal agencies should increase compensation for postdoctoral scholars. These are those elusive postdocs you've been talking about all day.
Yes, these postdocs. And so I want to just say...
They want to get paid now? I just acknowledged them.
We called this one in episode 2. All of our faithful listeners will know we addressed postdoc salary.
Yeah, go back and listen to that one.
What did we talk about in episode 2, Dan?
Well, we talked about the new proposed rules from President Obama about overtime pay and how those may or may not affect postdocs. But we also covered the idea that postdocs are really making less money than they should over the course of time.
That's right. And so this wasn't just something that we thought was a big deal, but this was actually a consensus recommendation from lots of people, is that one of the issues with biomedical research right now is that postdocs are not getting paid enough. And so actually, as I was looking into this one a little bit, one update that I wanted to share, Dan, since we did episode 2, is Stanford University. Have you heard of them?
I have. That one's out on the left coast.
That's on the left coast, many miles from here. But Stanford, as of October 1st, 2015, is bumping their starting postdoc pay to $50,000.
I call that the Hello PhD bump. They
That's
probably
right.
heard the episode.
I'm pretty sure they heard our episode too.
Tens of people have heard that episode. It's amazing.
We've got to do something about this.
Yep.
So if you're
cool.
out there and you're not at Stanford and you're a postdoc, make sure they hear episode 2 of the Hello PhD
Well,
podcast.
and what a great experiment. So by doing that, now Stanford will be one test case to see, does this make a difference for how postdocs are recruited, how they feel while they're there, how productive they are. Perfect.
Yeah, and I'm not sure why they did this. I just happened to see their postdoc salary page, but this was pretty significant. The NIH minimum, which they list, is $42,800 per year, and the previous Stanford starting salary for postdocs was a little over $44,000. So this represents a pretty significant
That's great, yeah.
increase, and I have to wonder if it had something to do with this Obama led a labor initiative that's coming up.
Yeah, what was the magic number that we cited in that episode? It's like 50,500.
Yeah, 52,000, something like that. I'm not sure.
Postdocs at Stanford, you may now eat.
That's correct, because I've heard Palo Alto is a very affordable place to live.
Number 5 was institutions and federal agencies should reduce graduate student and postdoc training periods. Now, I know this one is close to your heart.
Yeah, this one's going to generate a lot of discussion, I think. And I actually will say I was a little bit surprised this one made the list, though this is something that I think a lot about and agree with, right? And that is, Dan, how many years are you training before you're a PI?
What we cited in the last episode was the median age is like 37.
37 to get that first real job.
Yep.
And that's crazy. I mean,
you're not training for 37 years, but you are 37 years old at a median to be a PI.
Yeah, so I was glad to see there was a recommendation or at least a realization that the training period's too long. You know what I think, Dan? This is what I think. I'm going to throw this out there. I think graduate school should be 5 years and done for everybody.
Okay. That seems like a moderately scary idea to me.
Why does that seem scary?
I mean, there's the chance that you show up, you kind of hang out, like some of us did, and at the end you get the rubber stamp and the degree. But did you produce anything? Did you actually pick up the skills?
Well, when I think about why graduate school is stressful for certain people, and for me, one of the things that makes, I think, research, sort of a PhD program, a little bit stressful and demotivating is the lack of any set end time. I'm
totally with you. You are always at least a year from graduating. I don't care what year you are.
Yeah, you don't know when you're going to be done, and to me, that's very demotivating. I'm thinking about this. Imagine if you started graduate school in August of 2015, and you knew in May or August 2020 that was your graduation date. Your class was going to finish and graduate on that day. One, I think several things would happen. One, I think you would be much more motivated, right? Because you would see, this is the end, so I've really got to do X, Y, and Z.
Yeah, I've got this much time.
Because I know at that time I can do anything for a set period of time to meet a certain goal. And now you have a very tangible goal. So I think people are going to work harder and not just get lost and demotivated. But two, from the PI side, there certainly are situations where PIs will tend to hold on to a student.
I've observed that, yep.
Be wary to let a trained and somewhat affordable person, not wanting to let them go.
Oh, now did you complete the 15 iterations of this experiment that I asked about? Yeah.
If you just stayed 6 more months, you could get that one more paper done.
You could just produce that one mouse after 8 generations. It won't take...
Yeah, and think about the motivation for the faculty member, right? Saying, okay, this student's going to be done a year from now, 18 months from now. I need to do what I can to help them be productive in that last 18 months.
Yeah, I was really skeptical of this one because I thought the incentive structure would be off, that it wouldn't work out. But one of the recommendations in the article talked about what you do is you limit the funding. You get 5 years of fellowship from the NIH or whatever the funding agency is for that graduate student. And then I think the PI is aligned with the motivation of getting as much out of you as possible in that 5 years. They're not going to let you kind of languish on 6, 7, 8, 9 years.
Yeah, and that's how postdocs work, right? So the NIH already limits the amount of time a postdoc can be on grant funds.
And it makes it more important, though, I think, to have some other gates and checkpoints to say, maybe the prelim actually becomes important or something like it, so that we actually have some measure that, yes, you have reached this level of scientific training. You now know how to pull apart a research paper and design an experiment. I don't care that your experiments didn't work or your mouse died or whatever it is. That doesn't seem fair to me that somebody gets a degree and somebody doesn't based on luck. But you do need to see that the person has achieved a level of training that is commensurate with that degree.
No, I totally agree with that. But if you think about what did you learn in graduate school, what were really the important things that you learned that were necessary or at least useful for your next step as you moved on with life? It was not
how to cry silently.
It was not, how to do a Western blot or how to do mouse experiments, right? Those, I imagine, Dan,
it's how to load a gel without having it overflow a little well.
That's key. That is key. It is for a time, but I imagine
thumb control.
I'm actually a pointer finger pipetter.
Gosh, I'm leaving.
However, I think really the point of graduate school is to learn to think critically, to learn to identify what are the right questions, and then what are the most appropriate ways to isolate and answer those questions. And I believe that by 5 years you have gained those skills. And between years 5 and 7, are you really increasing in those skills? Probably not. And the reality is, very few, if any, people move on and do exactly the same technical things in their postdoc or whatever they move on to after graduate school that they were doing in graduate school.
I think that's fair. And maybe the test is you watch the news one night, and if you disagree with everything they say and you're like, I don't believe this research and that study has to be flawed, and that level of skepticism, I think, says you've achieved scientific training.
It's true. And for most careers anyway, before you move into them, you're doing a postdoc. So you're doing another training step. So why drag out graduate school is how I feel.
Well, so this is related to number 6, which is institutions and federal agencies should train students and postdocs for the breadth of careers available to them. And we talk about this a lot, that it is now an alternative career to be a PI, that it's really the small minority that are going on to that job, but the majority are doing a lot of other things. They're doing science writing, and they're working in full-time research labs and so many other positions.
Absolutely. And I was so glad to see this make the cut for a consensus recommendation, because I think for too long, there was at least the feel from trainees, from grad students and postdocs, that research faculty and academia were not supportive of quote unquote alternative careers, which is a term I hate because most people don't go into faculty positions, but there was very little support for non-academic faculty career paths.
This one's going to be interesting to execute, though, because the people who are designing these programs are PIs who became, They became faculty members. So obviously that's what they know, and that's what they believe was right for them, and that's what they're going to want to support. So it's going to have to be an outside influence that helps make it right.
It's true. And so I think an exciting development there is the NIH has actually become a leader. So the NIH being such a big funder of research in our country, if change really is going to happen, if the NIH says to do something, things will happen because they are the hand that feeds for biomedical research. And so one thing they've done recently is instituted a program that is called BEST. And so what BEST stands for is Broadening Experiences in Scientific Training. And this is really cool. This is
great acronym.
They're all about the acronyms. But this is in 17 different university sites. And what the BEST program does, it's a little different everywhere, but it actually provides opportunities for graduate students and postdocs to do internships in other fields, whether it's in industry, in government, in writing, in policy, whatever the student's interested in while they are doing their training, while they're in graduate school, while they're in a postdoc. So it really, one limitation to graduate school for students or postdocs interested in other careers was really it was hard to identify what do I want to do because you didn't have opportunities to actually get out there and explore. And so now this provides a legitimate funded way for you to get out of the lab and actually firsthand try out and explore some different careers. And along with that comes a lot of other career exploration at these university sites.
And if they need more ideas, NIH, please listen to the Hello PhD podcast. We talk about it pretty much every week.
That is right. That is right.
What do you have for number 7?
So number 7, institutions and federal agencies should shift support of trainees toward training grants and fellowships.
Oh, I'm sorry. I fell asleep on that one.
So number 8 is institutions and federal agencies should increase the use of staff scientists.
Yes, please.
I think this is so important.
This one, I loved it because I was so tired of seeing all of these great bench researchers go on to spend 42% of their time doing administration tasks. Like, to me, it makes so much sense that if you love science and you love working at the bench and you want to be the one making those discoveries, you should have a pathway to do that is not a dead end to you.
No, that's absolutely true. And, I remember as a postdoc, I was talking to my mentor one day, and, she was lamenting the fact that the thing she always loved to do was research, was science, was to be at the bench doing experiments. And how much of that do most PIs do as they advance in their career? None. Even if they wanted to, they don't really have time with the number of grants they have to write, the paperwork we talked about. And so, right now, there's really very few career options out there for someone who goes into a postdoc, really likes working at the bench, likes doing experiments, being in the lab. There's not much out there.
Yeah, it's a total mismatch. And there are other people that love science. I love science. I think I would have enjoyed maybe having a lab and thinking about experiments and planning them and writing grants, but I don't have the hands to get them done. You know what I'm saying? Like some people have that gift.
They do, and maybe they don't want to run their own lab. Maybe they don't want to be ultimately responsible for other people's funding, but they like to think about projects. They like to be an independent researcher. And so one of the recommendations was that universities actually legitimize this career path. And I think that's so important. And one of the quotes that I really liked from this article was, institutions should establish formal positions with pay scales attractive enough to make this career path desirable and viable, not just a default step for senior postdocs.
Yeah, I knew some staff scientists. They were adjunct faculty. I don't know what they call them in every location, but they were powerhouses. When they were in the lab, like they churned out papers like it was easy.
Oh yeah, and labs that have these staff scientist positions, and sometimes these are very limited in a department, really are productive. And as a student, I'm sure if any of you out there listening have a senior person who's a staff scientist in your lab, what a valuable resource that is as a new person coming in, to have this long-term established person who's so knowledgeable about the workings of the lab and the history of the lab. That can be such a resource.
Yeah, that's fantastic. I'm totally in favor of number 8.
So these were the 8 recommendations, although I really have to mention they threw in, I will call recommendation 8B, which did not officially make the cut, but it's one that's near dear to my heart, and I was so glad they mentioned it, and that is the importance of diversifying the scientific workforce. And so one of the things they said was the scientific community must also move quickly to identify and reform structural inequities such as unconscious bias in hiring and peer review, which is something we've talked about here on the podcast, and institutional cultures that select against women and underrepresented minorities.
You're here.
And so, I thought this was a great paper. I actually enjoyed the premise of what they did.
And not behind a paywall. I was excited that I could get it out in the cold, dark outside world.
That's right. So we have given you an overview, and we're going to post the link on the show notes. I tweeted this out a week or so ago. So I really recommend you take a look at this and use this to start some conversations where you are.
Yeah, leave your comments in the show notes. There's a place for you to write your own comments, and all you have to do is put in your email. And we would love to have the conversation with you there. Do you agree with these? Do you disagree? Did they totally, miss one that you think is important? Or are there some on here that you just think, that's not such a great idea?
Absolutely. And if there are other issues that you think are big problems for the sustainability of biomedical research or research in general, let us know those too, and we'll talk about them.
Now we need to do an episode on the actual environmental sustainability of lab research. I threw away so much plastic.
Lots of plastic.
Okay, well, let's move on to the etymology puzzle of the show.
Word puzzle of the week.
Last week's clue was a tricky one. I asked, what anatomical structure found in the towering elephant is named for the tiny mouse?
I have to admit, Dan, you have totally stumped me this week.
I have obfuscated this one. I made it a little bit of a red herring here. So the answer was muscle, which has very little to do with it has something to do with... You
sly dog.
Yeah. I could have said any animal, really, but I picked the elephant because I was hoping to throw people off. Muscle comes from Latin directly. Musculus. Are you familiar with musculus?
I am, and this is honestly true, Dan. So many times in my mind this week, I was trying to say tusculus, and it just wasn't working out for me.
Is that right? You thought it was the elephant's tusk?
That's a true story.
That is awesome. Tusculus. I like it. Well, mus is the Latin word for mouse, and musculus is diminutive. So it's the small mouse, tiny mouse. That was in the clue. But I thought this one was so fascinating because in the culture, they thought that muscles, and presumably they thought like biceps and things like that, looked like mice that were under the skin. Now, I don't know, maybe they didn't work out a lot, or maybe they had really big mice. I'm not really sure.
That's pretty weird.
Yeah, it is weird, except that it occurred in several other languages and cultures. So in in Greek, the word for mouse and muscle is mys, which is where we get myo, so like myocardial and myoglobin, things like that. It also happened in Slavonic, Old Church Slavonic, mysi was mouse and also muscle. German mouse and muscle. And in Arabic, which doesn't even sound like mouse, it is adala, which is muscle, and adal is field mouse. So it's like in different cultures throughout history, they made this association between mice and muscles. I have no idea why.
Now, Dan, is this also where the idea for the cartoon Mighty Mouse came from?
It has to be. I think these must have been some sort of word researchers that came up with this cartoon.
Who knew there was science behind Mighty
It's
Mouse?
Everywhere. Are you ready for the next clue?
Yeah, what do you got for next week?
Okay. So next week's clue is eating a bad sausage contaminated with this poison might cause drooping eyelids, double vision, and difficulty breathing. I'll read it again. Eating a bad sausage contaminated with this poison might cause drooping eyelids, double vision, and difficulty breathing. So I'm looking for a scientific word described by the clue, and once you get it, you'll find that the literal meaning of that science word is a phrase in the clue itself. If you think you know the answer, email it to puzzle@hellophd.com, and I'll select a winner randomly from the correct answers.
How did you know I grilled sausage today?
Hopefully it was not contaminated with this poison.
Well, I should know by tomorrow.
Yeah, we'll find out. If you get droopy eyelids and double vision, call me.
This was a fun week, Dan. I really enjoyed this topic.
That was really good, and we'll look forward to hearing from everybody on the web and everybody in Oregon.
Oregon, we're drinking your beer, and we're looking for you this week.
And it is delicious, and I killed it.
So, hey, thank you for listening. We would love to answer your questions on the show. Send us an email, podcast@hellophd.com, or send us a tweet at hellophd, or contact us on the Facebook page. We would love to answer your question here on the show.
We love you, Oregonians.
Thanks, and we'll talk to you next week.
Oregonians.
Bye.